The easiest way to do this is for me to give you the properties. There are 7 of them. And then what we'll end up doing is we'll put properties together and use more than one. Thank you so much. Properties. I don't make you memorize the name of the properties. I just want you to know what they do, okay? Try not to look at this and say, oh my gosh, that's so super easy. Because it's going to look really easy, but then we put it all together and everybody always gets stumped up. All right, first one. Product of powers. Again, you don't have to know the name of it. You just have to know what it does. Let's say I'm multiplying 2 things together. I'll give you a variable form and then a number form so you can see the difference. I'm multiplying these 2 things together. This is called the base. Yes, do y'all know that? This is called the what?
Power.
Power or exponent. So if we're multiplying 2 things, and the key here is that the bases are the same. Do you know how we simplify that?
X equals NM.
Close. Let me give it.
NM.
Let me say I have 2 to the 5th times 2 to the 3rd. You add the exponents. So when you are multiplying and the base is the same, we add the exponents. Now, if the base is not the same, you can't do this. Okay, so if I had... You should have learned these, yeah. You should have learned these. 3 to the 2nd times 2 to the 4th times 3 to the 5th simplifies as 2 to the 4th times... Yes, okay. You can't multiply these 2 bases together because they have these different exponents on them. So the only thing that you can do is combine the exponents of the bases that are the same. Does that make sense to everybody?
Yes, ma'am.
Is that not? It might have just been like maybe so. All right, so product of powers. Does that make sense? Okay. Property number 2. Y'all have that? You need me to wait a second.
Wait a second.
Okay. All right, let's do it. I'm going to go in a little different order than what your book goes in if you're following along in your book. Because it just makes sense to me to, if you do product of powers, I don't write that yet, that you follow it with quotient of powers. Yeah, we'll make sure I give you the right name. What does quotient mean? Y'all are so smart. Quotient of powers, okay? So again, this is one where the bases have to be the same. So if I have this, those bases are the same, yes? Can y'all see that color?
Yeah.
Okay. Those bases are the same, yes?
You're going to do x 5 minus 2.
Absolutely. The opposite of multiplication is division. So if I add, exactly, then I would subtract. So I say x to the 5 minus 2, which is x to the third. That's okay. Yeah, if you can see, turn them off. That's fine. Let's move on then. Let's talk about how about power of a power? Again, the names are not to me as important as you knowing the actual property and what it does. But it helps us give some order to our notes if we put the headings there. Power of a power. So I have, do I?
Double powers.
Double powers, that's right. I have something raised to a power that I am then going to raise to another power. Multiply. Multiply. Everybody always likes this when I lay the properties out. Then we put the properties together.
And then people are like,
Oh, and everybody thinks it's a whole new lesson. We'll work plenty of examples though. We'll probably save scientific notation till tomorrow.
Thank God.
What? You think scientific notation is easy?
We doing that. I said we doing that, man.
Mm-hmm.
we did it last year in geometry, I believe.
No.
Let's see. What number am I on?
4.
4. I like that y'all are talking to me more today.
I feel like we're getting more comfortable.
I appreciate it. It makes me more comfortable for sure. Power of a product.
So then you're going to divide it.
Product means what? Product. Multiply, right? All right, now think about this. I've got these two things being multiplied together, and they're raised to a power. Do you know what you do?
You're going to have
squared
to put 2
times
for
y.
each of them, right?
It does go to both, and I'm hesitant to talk about distributing, but understand this is very, very different than this. Why?
Plus
Because you're adding it.
squared plus y.
Can
X.
I am adding it, but understand, if I've got x times y squared, that means x times y times x times y, right?
But then
Multiplication
x
is
plus y.
commutative.
Y, and that's not commutative.
Correct.
You're the answer.
So I could rearrange this to say x times y times y, and that's the same thing, right?
Yeah.
So now, because I know when the bases are the same, I add the exponents. This is x squared times y squared, right? But here, because of that plus sign, that would tell me that x plus y times x plus y would have to be multiplied out. That's not going to give me x squared plus y squared. Okay, so don't ever make that mistake. If there's an exponent outside and you're multiplying, you can distribute. If you're adding or subtracting, though, never, ever, ever distribute that exponent. Does that make sense? Okay, so, and this was just kind of why it is what it is over here. So if you're multiplying inside the parentheses, you can distribute the exponent, okay? And it can go to everything. But if you're ever adding or subtracting, you can't distribute that exponent, because what that means is if you write this twice, you would have x squared plus xy plus xy plus y squared, which is not going to give you x squared plus y squared. So you cannot distribute it through whenever you're adding or subtracting, if that makes sense. Does that make sense to everybody? Remember, speak up if it doesn't, please, please, please. Okay. Do I need to slow down? Everybody okay? All right. Let's do, that was power of a product, so guess what I'm going to do next? Power of a quotient. What number am I on?
5.
Thank you. Remember how many I told you there were? 7. Good job, somebody was listening. All right, power of a quotient. Quotient means to divide. If
What did
I
power of a product mean?
multiply inside the parentheses.
When power of
You want me to go
power
back?
is just to multiply.
Yeah.
Outside and inside.
Same thing here.
What if you have a power of a power and you have x to the 5th plus y to the 2nd? Would you also distribute it and then do that?
No, you would have to write that, whatever that exponent is. What did you say? X to the 5th plus,
Plus, like, y to the 2nd.
and then there's something on the outside there. Whatever this is on the outside, let's say it's 3, that would tell you you have to write this binomial 3 times and multiply it out. 1, 2, 3. Multiply it out. And the only time you can distribute through is when there's no plus or minuses in the parentheses. All right.
Because that thought just came to my mind.
Yeah, no, I'm glad you asked that, because that's what everybody wants to do. So that's a good question. All right. Again, there's no plus or minuses. There's a division. It can go to both.
We do this without even realizing it.
You do. What would happen if they already had an exponent?
You would multiply it.
You would
You would add.
Good.
multiply them.
It's going to go to both, right?
Yeah.
So if I have x to the third to the sixth and y to the fifth to the sixth, if you have a power raised to a power, what do you do? Multiply. Think about raising a power, something that's already raised to a power, so it's really big, and then you raise it to another power, so it's really powerful. No pun intended. So you would have to multiply them because that's more powerful than adding. So this would be x to the 18 over y to the 30. So you just combine two properties in one doing that. You combined power of a quotient and power of a power. Does that make
We're going to
sense?
be doing that.
A little more complicated, but yes, doing that. Also understand it doesn't matter if they're variables or numbers there. I mean, if this was 2 to the third over 3 to the fifth raised to the sixth power, it's still 2 to the 18 over 3 to the 30. And there's nothing wrong with that.
What's the difference? I might need to put numbers.
Yeah, I was just saying a lot of students will get kind of caught up and confused when it changes from variables to numbers. If I give the notes in numbers, they'll get confused if it changes to variables and vice versa.
A number both together.
And we'll do some examples like that and show you what happens. Yeah, thank you. I forgot to hit record. All right, so zero exponent. Anything, with the exception of zero itself, raised to the zero power, what do you think you get? 1. Did y'all already know that? Have y'all? Okay. When did y'all learn this? Y'all learned all these properties in geometry?
Now we learn them in 11th grade.
Algebra 1?
Yeah, you taught us this, huh?
Algebra 1? I think we do it, yeah.
I was
Y'all are just the most familiar with them anytime I've taught it before.
We have these zero exponents and then
So kudos to your previous teacher. I don't know who that was who taught it.
I don't remember.
I like that.
Really?
She taught.
All right, let's finish. One more property. It's my favorite.
I thought I was your favorite.
Oh.
This is my favorite property. You're my favorite, Tanner. Oh, see, you like how I did that though, right? I can't pick a favorite student.
She likes you better than the sun.
I mean, but there's other haters in this school.
If you
Do
try
I?
to do a negative in the square root,
You are very, very true. And you're getting kind of ahead of the game because we are going to convert here in this chapter, we're going to convert exponents to radicals. Have y'all done that before too? Okay. All right, so negative exponents. Let's say I have x to the negative 2. Just like with, what?
You got a decimal property?
Just like with, this is the last property.
we have to make the negative imaginary number, so.
Oh, no. We're not doing all that. All right. We don't want to keep negative exponents. I'm going to put this over 1 because I can make anything into a fraction, put it over 1, yes? When you have a negative exponent, what you have to do is make it positive and move it. I like to move it. What I mean by move it is if it's in the numerator like it is here, it's going to move and there's not going to be anything here whenever it does move, so I'm going to hold the place with the 1 and it becomes positive and goes in the bottom. Okay? Only the piece that has the negative exponent moves. I just switched it, that's it.
Oh yeah, we've done this before.
Just
They
flips.
would cancel it out.
So here, I'm going to move the negative pieces, and I'll even let me put a z to the 5th up here. Only the negatives are moving, okay? And realize this 2, remember, it's its own piece. It's 2 times x to the negative 2 times e to the 5th.
2 times y.
Here's what, whenever I work these, here's what I do. I circle and do an arrow. That way I can remember, especially if there's more than one, I can kind of keep track of what's going where. This one's going up. So what do I end up with in the top? 2 y to the 3rd. Z to the 5th is still there, holding its place. Over.
X to the squared.
So just the x and the y split?
Yep, only the ones that have the negative exponent
Why the
split.
2 don't move and the 2 connected to that?
Well, it's connected, but it's not connected as far as it's its own piece. It's 2 times. Just like whenever you only move the x here because it's multiplied, you don't move the z with it even though it's multiplied to it. It's its own piece here. You don't move that with the x. Other questions about that? Y'all ready to do some examples?
Yes.
Okay, we'll start out easy.
Can we start off hard?
No.
2 plus 4.
All of that makes sense.
I will give you a hint as you look at these.
This already looks hard.
Uh-oh. Only combine. Okay, no, I'm not going to say that yet. We'll just do this. I can't combine the 4 and the 2 because the 2's got, like, that does not become 8 to the 5th. Does everybody see that? Okay, I just want to make sure. Remember, there's an imaginary 1 where there is no exponent.
Oh, we're just doing this one?
Yeah, so what should I do? What can I do?
5 and 2.
Okay, and do what? What happens to this 4?
It will become positive.
Do you agree with that? Do you see why I'm putting it in parentheses?
What happened to the 2 then?
I'm fixing to do it. I haven't got there. That is negative 16. That is positive 16. You see the difference? When you put a negative in front, that's implied like negative 1 times 4 to the 2nd.
Yeah.
And I'm saying this because of the way your calculators work whenever you put negative numbers in there.
Yeah.
So whenever you go order of operations, exponents always trump multiplication. So it would do negative 1 times 16 and give you negative 16. So to force it to go to the whole negative 4, I need to put that negative 4 in parentheses. Does that make sense? Okay. Times 2, and Juliana said do what to the 5 and the 2? Multiply. Does that make sense? Okay. Let's do another one.
It also looks like you're distributing it.
We did. We did. Because I'm multiplying inside, not adding or subtracting. How about... You try this one.
You're doing a hard one now.
No, not yet. I will tell you on these, just because you do them one way doesn't mean that's the only way to do it. Some of you will go through different things. There's not an order to these like there is when we're simplifying and doing PEMDAS. Yeah, just simplify it. I did this one because I want to show you the 2 different ways you could have done it. I'm assuming most of you are going through and adding. Is that what you did? 5 and negative 8 is negative 3. 6 is 3. Right? But what if I had looked at it and said, oh, I see a negative exponent that needs to move. Did anybody do that? Yeah? And up top you end up with W what? 11 over W8. And now what do you do with the exponents? Subtract them.
I just went through a whole bunch of steps.
The point is, if you look, I came back to the same thing. As long as you're doing legitimate steps, legitimate properties each time, the order's not that important, okay? It's just that you do. Y'all ready for a hard one?
Yes.
No.
Yes, ma'am.
The only thing I will say be careful of, as far as order goes, is if you see like parentheses, like this. Y'all are really catching on to this fast, though.
So boring, done it.
I know, I'm so impressed.
Is this my homework? It's gonna be like examples.
Yeah,
That's it.
yeah.
Hey, there's nothing more, like nothing extra.
And in fact, I'm going to add here. Try it.
Why would you do that?
To hit record again.
I didn't even know there was a 4 in front.
The four's gonna go away and the bottom's gonna.
That's because I added them in last minute. I apologize. I'm sorry. I really wanted you to see what happens when you simplify the fraction with the numbers like that. All right, what about up top? What'd you do up top first?
We basically distributed.
You do, absolutely. Distribute that 2 through. Since I'm multiplying inside those parentheses, so I get x negative 6.
Y.
And I'm just going to rewrite this bottom because I like to do it a step at a time. Now what?
Well, that's 6 come from that bottom.
What do you do? What'd y'all do?
The 4 versus 24.
Yeah, 4 divided by 24 is
X
1 over
-6 on the bottom.
X negative 6 on the bottom. Did anyone look at these X's and subtract them as they stood there? No, everybody move the 6 down, the X6. You could do that. All right, so if I move that down, I got Y6 over 6. This becomes X6, X5.
I think the other way.
And then you can subtract the y6.
Subtract those, I get 0, right? Well, I better write it. I better not mark it out. I better write it. So. Shh.
I thought it'd be on the bottom.
When you subtract them, you always keep it in the top.
Because then you have like a weird fraction.
Yep. Over 6x 11.
Yeah.
Why?
You can add the 6 and the 5.
Add those 2 x's there. What's y to the 0 power? So yes, what I was telling you whenever I looked at this, did anybody subtract initially? Had you subtracted here initially, if you did negative 6, let me move this out of the way. Negative 6 minus 5 is what? Negative 11. Over 6y6. And then you could have just moved the negative 11 down and you'd end up back where you were. Does that make sense? One more? Uno más! Uno más!
Are we gonna do our homework after this?
My son says he wants that candy where they go, uno más, uno más. Yes, we will. Yeah.
How much homework do you have?
It won't be too terribly much. I'll do one more example and I'll let you get started since y'all got a game tonight. Yeah. 6 minus 6. One more example. This is off your homework, actually. Keep it in mind. Keep it in mind. Yes, no, nope. You can do whatever as long as you're following properties. That's the nice thing about properties of exponents. BT dubs. How do you multiply fractions? Straight across. Top times top and bottom times bottom, right?
I know how to multiply decimals.
So whenever I have something like this, I tend to just make one big fraction bar. Helps me.
So if anything equals 1, will it just be the variable?
What do you mean it equals 1?
Like if I did y negative 3 minus y2, would that just be y? Or
That'd be y negative 5. Negative 3 minus 2 is negative 5. If it was positive 3 up top, that would be y to the first power. As y'all work through, don't look up until you've... No, you did? The question is, do you, despite which method you or not method, but what order you went through to get there, did you come back to
Oh, no, that is
this?
wrong.
Tell me what you think. You got to talk to me.
Hold on.
I see some thumbs up. I hear some not yets.
Not yet.
Not yet. We don't understand it yet, or not yet. You're just copying.
I'm at that part.
I'm just
Not yet, you done.
Okay.
Crap.
I forgot to record it again. Here's another example video. All right, what y'all do first?
I brought
Put
up
the
the
bottom y
y
negative 1 on top.
Okay. 2x2y, and then you got that y negative 1 that comes up.
Y squared.
Yes. All right. Did anybody subtract the y's here and say 1 minus negative 1 is 2?
Yes.
That's what I did
And
too.
then I divided 2 by
You simplified 2 and 6? Okay. So you got x2, y2 over 3x.
How did you do that?
I brought the X up.
The x's, you simplified the x's. 2 minus 1 is 1. I would say that's simplified, would y'all?
yeah.
Yeah.
Make sense?